Hey guys, how's it going? So, my name is Joseph Pasek, and I'm on a quest to do nothing. So, to first start out, who am I? As I said, my name is Joseph Pasek, and I am the senior engineer of graphics and optimization at Schell Games. And I've been working professionally with Unity since 2009, so if anybody's been keeping track, that was version 2.1, which was Mac-only editor at that point in time. I feel kind of old saying that. I joined Schell Games in 2013, though, to work on a game called The World of Lexica. And since then, I've been supporting multiple projects, including I Expect You to Die, which is actually available for demo done in the floor space. It's coming out on December 6th, I believe, for Oculus Touch, and we are also going to be launching for PlayStation VR. So please come check us out if you haven't already. Say hi. So what is this quest? Well, it's not an attempt to be lazy. The name might be a little bit misleading there, but it's actually quite the opposite. Doing nothing is actually fairly easy, so it really wouldn't make that great of a subject matter if that's all I was going to talk about. So it's actually an attempt to work in the most efficient way possible. And it's kind of like what a computer does when you think about it. Like a computer just tries to get all of its tasks out of the way so that it can go back to doing nothing. It just wants to be a box with electricity running through it that does nothing. So for me personally, like I said, I support a multiple amount of projects in separate versions of Unity at any given time. I think my record's like 5 or 6. And that means that I need to maximize my desk time because I'm constantly firefighting or I'm in meetings and I just don't have a lot of desk time in any given day. So that means I need to work smart and not hard. For that, we need tools. Now, if you've been working in Unity for any amount of time, you've probably written a tool or two, probably written an editor script that does something, and usually these are pretty project specific, but they might not be. Now, Schell Games actually invests very heavily in tools development, so much so that we have a proprietary Unity framework that's maintained by a number of engineers, myself included. But tools, they take time themselves. They get old, they get outdated, they break, they need maintenance. And that takes a lot of time, and that really doesn't do a lot for my quest to do nothing. So today, I'm going to talk about 3 framework tools that I've written, and how I've minimized the amount of time that it takes to maintain them so that it not only helps the content creators that are using them, but it also helps me. And those tools are an extended version of the standard shader, an extension for material editor, and an asset importing system. So first off, the extended standard shader. Now, the motivation behind this was pretty simple. The artist just wanted to have everything that the standard shader does, but more. Well, that brought along some hurdles. First of all, CG isn't object-oriented, so you can't really just override or extend the standard shader the same way you could like a C# class. So I had to think of different ways around this. Well, surface shaders are cool. You can go ahead and just get all the standard lighting pipeline stuff really quickly, but the problem is that all the features of the standard shader don't ship with that. So that's kind of out. Doesn't really do a lot for my quest to do nothing. Ultimately, though, the artist really just wanted the standard shader's inspector, and that gave me a little bit of freedom to do whatever I needed to do to get to that point, as long as their end interface was exactly the same. So to solve the first problem, we came up with just a process for cloning and branching out the built-in Unity shader source that they provide to you with every version that gets released. That's done through a pretty simple editor dialog that I don't think anyone could possibly mess this up. It's so small, but artists surprise me all the time. So to maintain the source and make sure that it stays up to date in between Unity versions, we actually just use like a merge tool like preform merge to just make sure that anything gets integrated in with each major revision step. Next, we just inject precompiler branching so that we can very quickly override and bypass any parts of the shader that we want to swap out. And then finally, we steal the standard shader GUI so that keeps our artists happy. And I mean, I love pleasing artists. So declaring overrides is actually a pretty simple thing. You simply just declare some special defines inside of the CG include block. And it's done with a very strict but simple naming convention. So specifying something like custom falbedo into that CG include block basically says we want to override the albedo function. Pretty simple. What that tells the compiler is we want to point to a special custom albedo CG inc file instead of using the built-in Unity source that's provided. The cool thing about this is that the core CG is going to stay exactly the same. We don't touch it. We simply just pipe around it. So we get some pretty cool results, and even though this is a relatively simple example, it's still pretty neat, where we can just have the exact standard shader that everybody knows and loves and has used before, and we can just add some interpolative blend in the albedo to get this nice burn effect that we use to reveal secret messages in I expect you to die. So the last piece of this puzzle was to get the editor working and make sure that it was exactly what the artists are used to doing. So that brings along some caveats, like maybe I can just extend the standard shader GUI. Well, it's actually internal, so no, I can't. But shader GUI is public, and that's what standard shader GUI extends from. So maybe there's a backdoor. We can use reflection to actually gain access to that type, and then activator to create an instance of it. And then we simply just cast down to shader GUI and invoke the onGUI function. That gives us everything that we need to draw the standard shader GUI as it exists. So, but we're not going to stop there, because since we're extending the standard shader, we're probably adding some properties. And because we're adding some properties, we're going to need to draw those properties with all the other properties that have already been drawn with the standard shader GUI. So you can use shader util class to actually gain information about those shaders. So we simply just compare it against the built-in standard shader, and we just build a diff list of all the properties that are contained in one and not the other. At that point in time, we can just iterate through that list using material editor.shader property, which will just draw the property as it is with all of the property drawers that you would apply to those property blocks. And you have everything that you need right there. And the greatest part about this is that it literally does update itself. I implemented this, I believe, in either late 5.1 or early 5.2, and I have not touched it since. So in 5.3 and 5.4, Unity's added some additional fields, some additional properties. I haven't had to do anything, which is exactly what my quest is to do. So next up, the material editor extensions. We wanted to make sure that we could manage the render queue from inside of the material editor as opposed to going to the debug menu. Now, because of that, it was only in the debug menu. We had to bring that out. And by doing that, we're able to unblock ourselves from certain things. Like, I don't know if you've ever had to do a transparent material that somebody has changed the render queue behind the scenes, and then suddenly things aren't drawing in the right order, because in the transparent queue, that actually matters. Here, this makes it completely obvious to you and to the artist why that is happening, that they have actually overridden the render queue. We've also added some additional things like scene level instancing, which you used to only have access through script. And simple things like on-preview GUI icons. And those are mostly cosmetic, but it does allow for easy call-outs to say, hey, there's something special about this material. Most of all, we added the really cool property drawers. And I don't just mean the regular property drawers, I mean property drawers that maintain state. And Unity's editors are typically stateless, so being able for property drawers to actually talk to each other is going to enable us to do some really, really cool things. So just a couple of examples. We'll start off with an optional texture. And basically what this is going to do is say, when you have a texture assigned to that particular slot, we're going to enable a keyword. And that's going to pipe your shader to a specific variant. And basically what that's going to do is you're going to be able to compile out code that doesn't need to be there if that particular shader isn't defined. That'll be useful for things like normal maps, where you don't need to do any tangential transformations if the normal map is neutral. So the next thing we added were things like vector 2 and vector 3 fields, which simply just reskin the vector 4 fields that Unity supplies to you, because by default, any vector property in a shader is going to be a vector 4. And you might have some useless fields there that you don't really need, and artists are going to punch things into those fields, and they're going to ask you, hey, why is this not working? It doesn't do anything. Well, that's because it's not used. So this kind of prevents that from happening at all. We also added packed data. And that's basically just saying, just draw all of the things that are in vector 4, but as a separate like float component. And the advantage there is if you're actually packing your data, it's a little bit more efficient to write programmatically when you're uploading those shader variables. We also added a tag options dropdown, which is basically just going to allow you to add particular replacement tags that you would normally have to either write a script around or just modify the shader by hand. So not so simple examples. Like I said, we could get these property drawers to actually talk to each other. That means we can enable for dependent property fields. And what you get with this is actually, that's dead. What you actually get here are situations where you have a bunch of fields that correspond to another field, and they're not going to do anything unless that field has something in it. So here you can see that we have a texture, and below the float field is actually enabled, but if the texture is not there, it's disabled. And that's just going to stop artists from tweaking values that are just not even used in that context. So next, we actually allow to change the render queue. And changing the render queue through the material editor is nothing new. Like Unity does it in their standard shader GUI, but it's all hard-coded. This is actually two properties working together to draw a unified control where you can specify the render queue in an offset. And what that gives you is the ability to modify the render queue directly inside of the material editor without having to write any custom code around that. It's just simply injecting these two things. So kind of cosmetic, but also pretty cool. The ability to just color fields, which might not really seem like that big of a deal, but say you want to tie this particular value to something like the red channel of a texture or the red channel of a vertex color. This is going to allow the artist to know that we have established a relationship between that value and that particular texture. So the coolest thing by far that we were able to do with this was actually add positional gizmos, scene gizmos, to our materials. So simply by adding this, we get scene gizmos directly in the editor as if we've written a custom inspector. So what's awesome about this is I've written a point light that now, because I've selected that game object in the scene and that has that shader, that drawer is actually going to tie into the scene editor and draw this gizmo so that we can modify the properties visually. What's also pretty cool about this is the fact that these are decorators, so you can use them in conjunction with each other. So as you can see, the field is actually tinted yellow, so that's the background color. It is a vector 3, so we're drawing with the vector 3 control, and then we're also using the positions gizmo. So all those things are just going to work together. So they're completely modular, and you can get some really complex behavior without having to, well, write new material editors that are one-off or write, no more additional one-off components for this either. It's just simply all handled in the attribute. So the way this is accomplished is we actually have a custom material editor that just simply extends the original. And we do one thing different, though. Instead of just calling base.onInspector GUI, we simply just override it entirely and wrap any of the internal calls that it does with our own. And as I mentioned, we're using a lot of decorators. And at that point in time, they actually get invoked before any of the controls get drawn. So we can use that to cache the state that we're trying to modify. We can evaluate it in the decorator and update the state. At that point in time, we can draw our controls and then just clear the state right after for the next control to be drawn. And what's really, really cool about that is that the shader GUI coexists. So because shader GUI is actually invoked from within Material Editor, we actually get all these cool little features for free, and our extended standard shader can use it with no additional effort. So the last thing I really wanted to talk about is probably the coolest thing that we've done. It's the motivation behind this was that we needed a lot of assets that were very similar to have the same import settings, but we didn't want to modify them by hand or have to write scripts that were very specific. So essentially, we're just recursively managing import settings by directory, and we do this through an asset. We create an import settings asset for that particular importer type. And instead of writing a script now, we have something that the content creators can use that they can author themselves and manage their own directories. So in this example, we have a bunch of different UI textures that are being set to be sprite 2D in their texture types, and they're also having their alpha set to be transparent. And what's going to happen is if an artist adds an additional texture, just like if you were to write an importer script, this thing is going to handle itself. It's going to come in with those import settings. You don't have to worry about it at all. So there's no additional engineering support there. But how it works is way cooler than what it does, and especially with how it assists me in my quest to do nothing. So a little bit of backstory. We had an original version of this that was completely project specific, and it was also completely hard-coded. So the problem with this was that because it was hard-coded, if Unity had a new enumeration or a new property that was added to an importer type, we had to support that by hand. And again, since I'm on a quest to do nothing, that just seems like a whole lot of work. So we got this really crazy idea, like maybe we could just make this thing update itself. Since we had to support the multiple versions of Unity, that was going to be a huge focus. And when I say a lot of versions of Unity, I think I had like 17 or 18 installs on my machine at any given time. It's ridiculous. So we made this version aware. And by version aware, what I mean is we kick off a process on initialize on load. So whenever the assembly is reloaded, we're going to write or evaluate a file to the library. The library. First try. OK. So we write one file for the entire system at large, and then a file for each additional asset importer that we have. And basically what this is just going to hold on to is the version of Unity that it was serialized under, and what internal version they each have their own increment counter, so you can set versions of those particular importers to let people know that they need to re-import, or let Unity know that it needs to re-import. Once Unity is loaded up and we notice that the version of Unity has changed, we kick off this process where we scrape the entire assembly and we do Codegen to qualify any types that were not previously serialized for that particular importer. And we do this based off of a pretty simple string template. And what we're going to do here is we're actually just going to extend what is at its root a scriptable object class. And it's generic. And that's really important because it's going to qualify our types for polymorphic serialization. And I'm going to get to that in just a second. But keep that in mind because it is really important. So at that point, where we have passed the Codegen step, we're going to collect all the asset importer classes via reflection. And we're going to generate a hash map which binds those properties to its respective importer type. At that point in time, when a user creates the importer asset, we're going to look up that table, and we're going to generate all of the properties as sub-assets to that importer asset and cache them inside of an array, which then, again, they're polymorphically serialized. And polymorphic serialization is not something that Unity does very easily, and it only works with two things, monobehaviors and scriptable objects. Fortunately, scriptable objects are really powerful and really easy to use, and they make great assets. So that saves us there. When it actually comes to drawing these things, though, it's pretty much just iterating through the list and just calling the property field to draw the default property drawer. But it looks kind of lame, and it's not really in any order that makes any sense. It's pretty dissonant. So for an artist or any other content creator, they're probably not going to know how to use this very well. Things aren't really going to make sense. So we added a couple of functions to be able to group things or draw based on a per property basis what control we want to show. And that's going to make things way nicer for them. Of course, this is a manual step, but it's completely modular. And like I said, it's going to have a default drawer anyway. So if we can't get to supporting it in time, well, it's fine because it's going to appear at the bottom of that list. It's just not going to look very good. But again, we don't have to do anything right away. It's not blocking the artists from actually making those changes themselves. So to recap, we have an extended standard shader. And the way that keeps us from doing too much work is we're using a bunch of backdoors. We have some material editor extensions, and it's very important to stay modular with these because now we have all of these particular little building blocks that we'll be able to make really cool tools out of with no additional effort. And an asset importing system which literally takes automation to the next level. I guess the important takeaways here are you should let the editor do the work for you whenever possible. You should find backdoors if your public APIs aren't available. And you should never forget yourself, because you should build tools that work for you. If you're building tools for everybody else, it's very easy to let that go to the wayside, and you're the one who's spending all the time. You're important too. Build tools that work for you. So thank you.